Hey guys, today I'm going to teach you how to find the area of composite figures. By the end of this lesson, you'll be able to use formulas for area of parallelograms, triangles, trapezoids, and circles to find the area of composite figures, which are just shapes that are made up of all the shapes that we've learned about so far. So go ahead and get out your binder, turn to the math section, and let's get ready to take some notes. All right, so like I said, a composite figure is made up of two or more shapes. It's a shape made up of other shapes. So you can look here at three examples. A stop sign, there's this 2D picture of a lamp, and there's this door. So you can see, like on the door, I see some rectangles, I see some circles. On the lamp, I see some circles, some trapezoids, and we're going to get into that here in a second. We can find the area of a composite figure by adding or subtracting the area from each shape. So usually when you think area, you're thinking you're going to multiply something, especially with like rectangles or parallelograms, it's going to be base times height. However, when you have a bunch of different triangles and rectangles, like we have here, or we have different shapes like circles or rectangles or squares, you're going to be adding up all of the areas together. That's what makes a compound or composite figure. So for example, look at all these 2D figures here, and let's just talk about what shapes these are composed of. This is obviously an octagon because it has 8 sides and it's a stop sign, but an octagon can be looked at like it's made up of 8 triangles. When you divide the stop sign up like that, it's a lot easier to look at area if you had, for example, the length of this side and maybe the height to the middle. In that case, you would just find the area of one triangle and then multiply it by 8. So composite figures are more real world because they're not exactly perfect, easy shapes. Instead, you'll have to use what you know about other shapes like triangles and the area of triangles, and then use some problem solving and logic to figure out the area of the whole thing. Let's look at the same thing with the lamp. I'm shading right now in blue trapezoids. I know they're trapezoids because I can see that they have 2 bases and then these 2 slanty sides. So you have 4 trapezoids. You also have this circle. That's what I just put in red. You can see there's a rectangle here, and then you can see there's another trapezoid at the bottom. So that's a different trapezoid here in yellow. It's not a triangle because it doesn't have like a pointing end. It's actually got a length right here at the bottom. So that's a trapezoid at the bottom. I also want to point out that you can look at these different ways. For example, if I knew the length of that base and this height, then I could look at this shape here at the top of this lamp shape. I could look at that as a whole trapezoid in itself. So there's different ways to look at these. Okay, so the next thing we're going to look at is the door. Before I get to that, I just want to point out that in the stop sign example, we would have found the area of these triangles and added it to the area of that rectangle. For the lamp, we could have found the area of all these different trapezoids and added them to the area of the circle or the rectangle. But for the door, this is an example where it might be something we would need to subtract to find. For example, if I was given the length or the width of this whole door and the length and the width of these, I could also be asked to find the area of the part of the door that's not paned. These little parts of the door may be windows. Maybe we want to take those out. So in some of these compound figures, you'll have to add, like these two. But sometimes you'll have to subtract. And again, in this door, you see all these rectangles, and you also see a couple circles here for where the doorknob is. So the important strategy with these composite figures is going to be able to realize what shapes are within the bigger shape. That's called decomposing the figure. So when it says decompose this figure, I need to see what are the shapes that are making up this weird one. There's 2 of them. So see if you can figure out right now. Go ahead and pause the video. See if you can figure out how you would decompose this house-looking figure here. All right, so the cool thing about these composite figures is that there's different ways you can actually decompose these. So the first thing that I look at when I see this is I think about like a little house, and I think this is the roof on the house. So I have a triangle and a rectangle. But I also want to show you that you could have done it like this, and you could see, okay, this is trapezoid 1 and trapezoid 2. And you have enough measurements that way to also figure out the area of this composite figure. So there's multiple different ways to do this. I'm going to go through it the way that I first saw it, and I'm going to show you the way that I personally did this one. But if you did it the way with the trapezoid, you should get the same answer. So let's go ahead and look at this now with the first shape being a triangle. So again, I see that triangle as the roof of this house. So if I'm going to find the area of the whole shape, I need to find the area of each shape. To find the area of a triangle, I have to use the formula area equals 1/2 times the base times the height. You could also think area equals base times the height divided by 2. Now that I've got the formula, I'm going to always plug in the values that I have. This part might be a little bit tricky because when you look at this, you need a base and a height. It's not given to me right here directly on the triangle. So I got to kind of solve for this. So I'm not given the length of the red line here, but what I am given is the length of this bottom line. It's the same length. So the length of this red line is 9 feet as well. And then the height of the triangle I need, and remember that's the distance from the top to the bottom here. Again, I'm not given that, but what I'm given is that it's 12 feet total, but to here, to the red line, is 8 feet. That means that I'm going to have a height of 12 minus those 8 feet. That means that my height is going to be 4. And again, in case you missed that, the whole thing is 12. Part of that to here is 8, and I can see that on the other side. So if this much is 8, the rest has to be 4 to make 12. That's how I know that the height is 4 feet. So I plugged in my values for base and height, and I use parentheses because when I know that things are next to each other in parentheses, it means they're being multiplied. Now I'm going to go ahead and just multiply those things out. When I do, I get the area. I got 18 square feet. Again, remember, you're not done because I only found the area of the triangle. The whole shape involves two shapes, the triangle and a rectangle. So now I need to find the area of the rectangle here. I'm going to do that by using the formula for area of a rectangle. I know that the area of a rectangle or any parallelogram is base times height. My base is 9 feet and my height is 8 feet. So I'm going to plug those values into my equation or formula. I plugged those values in, 9 and 8, went ahead and simplified, so I got an area of 72 square feet. Finally, this is a composite figure, which means it's made up of two things, the triangle and the rectangle. So the total area of the whole shape is going to be the sum of the triangle's area and the rectangle's area. So I add 72 and 18, which gives me a combined area of 90 square feet. Which, again, you could have gotten if you did it the other way and you made two trapezoids. Do whichever way works for you. Let's go ahead and move on to our second example. I want you to try this by yourself and then press play whenever you're ready to check. All right, so just like the last one, there's multiple different ways you can divide this shape. You could draw a line here and make two trapezoids. But the first thing that I saw was another triangle on top of a rectangle. That to me looks like the easiest way to do this. So a question that I get a lot from people is, how do I know what this 9 is referring to? How do I know how much of that 9 is the length or the width? Same for like the 15 or the 5. Well, it's always going to be probably like in the middle of what it's referring to. So this is the 5 line, and that's only going to go with the 5. This is the 9 line because it's in the middle of that line. So it's kind of in the middle, and it's right next to the line that it takes the measurement of. I just wanted to point that out because I know some people get confused on what is the number referring to. Okay, so let's find the area of the triangle first. Just like the last time, I know that the formula for area of a triangle is 1/2 times the base times the height. So I need to find the red line's base length because I don't have it right away. So I need to look in other parts of this shape. And if you look, that red line matches with this red line. 15 would be the length of the base of this triangle. So I'm going to plug those values into my formula. I'd use 0.5 instead of 1/2 because I know that those are equivalent. 0.5 is the decimal version of 1/2. And if I'm using my phone calculator, to me, that's a lot quicker to type in. And I'm going to multiply that by the base of 15 meters times the height of 5 meters. After multiplying, my product is an area of 37.5 square meters. Now let's move on to our next shape. I can see that this is a rectangle because it's got right angles. It's got two sets of matching sides. So this is a rectangle or a parallelogram. So you're going to use the formula base times height or length times width. So I'm going to multiply 15 and 9 because I know that this is the length, this is the width. That's going to give me a total area of 135 square meters for the area of the rectangle. So again, this is a composite figure made up of a triangle and a rectangle. And I want to know the area of the whole shape. So I need to add this area plus this area. Remember, that's all the space inside. That's going to give me a total area of 172.5 square meters. All right, so in both these examples, we had two distinct shapes. I saw a triangle and a rectangle in both these shapes. Again, you could divide it and you could see two trapezoids and you get the same answer. However, sometimes a composite figure can include overlapping shapes. So if you look here on the right, you have a rectangle, but inside of it is this parallelogram. If I wanted to find the area of just the shaded part of this, how do you think I could find the area of just the shaded region? This is whenever you would want to use subtraction instead of addition. If I was given the information that I needed to find the area of the rectangle, I would find the area of the rectangle, then I would find the area of the parallelogram. Then I would subtract. Their difference will give me just the area of the shaded region. So let's look at this example below. Number 1 gives me a trapezoid. And inside of the trapezoid is like a hole cut out. And it's a hole in the shape of a rectangle. I just want to know the area of the shaded region. So let's follow the instructions that we just wrote above. We're going to find the area of the big shape, in this case a trapezoid, then we're going to find the area of the parallelogram, or in this case the rectangle. And then we're going to subtract to find the difference. Take a second, see if you can do that now by yourself, and then press play whenever you're ready to check. All right, so hopefully you started out using the formula of area of a trapezoid to find the area of the trapezoid, and then you could subtract the rectangle's area. So the formula for area of a trapezoid is half of base 1 plus base 2 times the height. So let's go ahead and start by plugging in those values. 15 and 10 are my bases. 8 is my height, so I just plug those into this formula. Then I need to simplify. 15 plus 10 is 25, and then this is where you can use your commutative property, because instead of taking half of 25, it'd be easier to take half of 8, which is 4. 4 times 25 is a lot easier, because you know that 4 quarters makes $1. So the area of all of this is 100 square inches. However, there's the hole in the middle, so we need to find the area of that rectangle and then subtract it. To find the area of the rectangle, you use this formula. And in this case, the base and height are 5 and 7. Remember, I'm trying to get inside here and take out that hole. So do 5 times 7, and your area will be 35 square inches, again, for the inside hole here of that rectangle. Now, I need to figure out what's the area of just the shaded part. So I need to take out this hole. That area of the hole is 35 inches squared. So 100 minus 35 will give us our area of just the shaded region. 100 minus 35 is 65, and it's inches squared because it's the area of the shaded region. Let's look at number 2. See if you can do it by yourself, and then you can fast forward or press play whenever you're ready to check. Okay, so for number 2, there's multiple different ways you can do this one. So I'm just going to go through it the way I would look at this, and hopefully that'll help you. So obviously when I start out looking at a problem like this, I want to read it, and when I read it, it says how many square feet of landscaping will be around the patio. So that means that I'm looking for the area of the landscape combined, not the patio. There's not a shaded region on here drawn, but based on the question, I know that I need to take out this patio area. That all is going to be erased from the total area that I'm looking for. So now this is a question just about problem solving, and it's really just how you determine which shapes you're decomposing. When I looked at this, I saw a rectangle here, here, and here. So I have 4 rectangles, is how I looked at it. And I know that this top one is the same as the bottom one. It's a 14 by 3. So again, I'm using this width and this length. 14 by 3 will be the area of the big rectangle part of the landscape. 14 times 3 is 42. So I know that this is 42 and this is 42. Now I'm going to find the area of the smaller rectangles. Now, in the picture, it looks like a square. However, don't just trust the picture. Let's make sure we can find that mathematically. So I need a length and a width for this rectangle. I have a length or width of 3, and I'm looking for my height. So I know that in total here, I have 8. I know that this part is 3, so the difference will be what I'm putting here in purple. Again, if the whole thing is 8, take off this part that's 3, then what's left is in purple. 8 minus 3 is 5. Now I know that 5 times 3 will give me the area of this box here and this box here. So I got 15 for each one. Now I'm looking for the total area of the landscape. So I'm going to add 42, 15, 42, and 15. That gives me 114 square feet. And if you did it differently and got the same answer, that's totally fine. All right, so I'm not actually going to look at number 4 in this video, but I do want to go over number 3 with you because this is a little bit different. You can tell from the picture, but it also tells you in the problem that you have a square and a semicircle. A semicircle here is like a half circle. So all you would do differently is find the area of what a whole circle would be and then divide it by 2. So go ahead and take a second, see if you can figure this out. You're only given one piece of information, but see if you can figure it out all by yourself and then press play whenever you're ready to check. All right, so I know I need to find the area of the square. I know the formula for area of a square or any rectangular parallelogram is base times height. Since it's a square, I know that all of these measurements will be 12 because in a square, every side is equal. So I'm going to do 12 times 12 to get an area of 144 square inches. Now I need to find the area of the semicircle. The formula for area of a circle is pi r squared. Now, this is where it might get a little confusing. I only have half the circle here, but you've got to imagine I have a whole circle, and it would go around like this. If I had that, then 12 would be the diameter. It's the length all the way across. So I don't need the diameter for the formula. I need the radius. Remember, radius is half the diameter. So the measurement of half of this circle would be 6. So that's what I plug into my formula. A equals pi times 6 squared. You know, 6 squared is not 6 times 2. It's 6 times 6, which is 36. Okay, so let me stop real quick and just remind you. It is important to remember that I'm trying to find the area of half of the circle, not the whole thing. However, the formula we've been using and plugging these values in and simplifying has been for the entire circle. So I just want to remind you that at the end, you are going to have to divide by 2. So initially when you simplify, you get about 113.04. But don't forget, you have to divide by 2 since it's half the circle, which gave me an area of 56.52 inches squared. Since it said what's the total area of this figure, I have one last step, which is going to be to add these two areas. So the combined area of this composite figure is about 200.52 square inches. All right, guys, that's it. If you made it to the end of this video, go ahead and put in the comments, what do you think this composite figure looks like? It's a shape, it's made up of a big rectangle, circles, semicircles. Take a second, look at it, see if you can tell me what you think that looks like and put that in the comments. Today, we learned all about area of composite figures. So now you should be able to use formulas for area of parallelograms, triangles, trapezoids, and circles to find the area of composite figures. So go ahead and turn back to the calendar and click any other assignments you have left for the day. Let me know if you have any questions. Bye.